Hello, Honors Dragon Pre-Calc students. Hopefully you had a good day yesterday. Happy Friday to all of you. Got a nice weekend ahead. Today I thought I would discuss the section 1.4 worksheet with you. This is worksheet number 2, and this was Thursday's assignment. So I just wanted to go through a couple of questions and concepts with you to kind of review the translations and reflections of these graphs. So here we have this function. I have the x and the y values labeled as we discussed in yesterday's lesson. And just kind of looking at some of these problems here, kind of thinking about what happens to the graph. If we look at number 1, I'm noticing that the x value is negative. So if I make the x value negative, that means this graph reflects over the y-axis. Because all the x values are becoming negative. The other thing that happens to this graph is that it also goes up 2 units. So that's 2 things going on with this graph. So I'm going to make my little t-chart. That was a bad part of the t-chart there, bad vertical line. That looks much better. So I'm going to try and apply that information to my t-chart to create some ordered pairs. So I know the x has to be negative, so I'm going to write a little negative x here to remind myself to make the x negatives. And then the y has to go up 2, which really means I'm adding 2 to move it up vertically. So looking at my current points, I'm going to work with x first. I'm going to take all the x's and make them negative. So I still have a 0. Now I got a -1, a -1.5, and a -2. The second thing I'm going to do, it says the y has to go up because this graph moves up. So that means I'm going to take all the y values and add 2 to them. So now I have a 3, another 3, a 4, and back down to a 3. So these are the new ordered pairs that I should be graphing. So I should see that it reflects over the y-axis, and then it also has moved up 2 units. So let's see if I can plot these points. And I know it looks like a pretty small graph, and that's because we're counting by ones, and the graph that's drawn was kind of nice and big and spaced, but this is going to be a tiny little graph. However, it should still look the same. So kind of comparing it to what we had, I can see that it flipped over the y-axis, and it's also shifted up 2. So on the y-axis, it initially was at 0, 1, and now it's up at 0, 3. And it also shifted or flipped over the y-axis. All right, let's look at a couple others. Number 2, just kind of talking about what happens with that. The negative sign outside is a reflection over the x-axis. And that +2 really is x minus a -2. That goes right. Or I'm sorry, not right, left. Number 3, we have 2f of x and then -3. Nothing's inside the parentheses with the x, so the x values shouldn't change in your original ordered pairs. But the y values are being doubled, so we know this is a vertical stretch. And then it's moving down 3. So when you go to calculate your y's, you're doubling them first, and then you're subtracting 3 from them. Looking at number 4, there's 2 things happening here with number 4 as well. There's the negative sign, which means it's reflecting over the x. And then the 3 is that vertical stretch. So again, nothing's in parentheses with x. That means the x isn't changing. So I would be taking all my y values and multiplying them by a -3. The negative makes it flip over the x, and then the 3 makes it stretch vertically. The last one that you had to graph here had a 2 in front. So this 2 in front makes it a vertical stretch. The plus 3 on the back also means that it's going to move up 3. So those are the two things happening with y. And then the x, this is really x minus a negative 1. This graph is moving left 1. So thinking about the numbers here in my t-chart, if I'm moving left 1, my x has to go left 1. And then thinking about the y's, I have to double y, and then I need to move up 3. So going back to the original x values, we have a 0, 1, 1.5, and 2. And then the y values were 1, 1, 2, 1. Okay, so let's look at x first. I need to move x left 1. So that means I have to subtract 1 from all of the x's. So it's now a negative 1, a 0, a 0.5, and then a positive 1. My y values, I need to double them first. So I have to take 2 times y, multiplication before addition or subtraction. And then I need to add 3. So I'm going to double it. 1 times 1 is 2, add 3. Double 2, I get 4, add 3. And then I double the 1, and then I add 3. So those should be your new ordered pairs. After I have those ordered pairs, I'm going to plot my points. And I have a very similar graph to what we started with. The graph has shifted up, and it's also steeper. And the part that I can tell is steeper is that mine's a little iffy looking here. So if I can make this a little better, but it's that triangle part perverse, that peak part, not quite a triangle, but that's the part that has gotten steeper. It's been doubled. So hopefully that helped kind of working through those couple of problems. Let's look at number 6. This one was a little different. We have to kind of describe or write an equation based off of the description that's provided here. And we have a given equation. Our given equation is f of x equals 3x minus 2. It says write a new equation g of x if the graph of g is obtained from the graph of x by the reflection provided or described. So this one says we're reflecting across the x or the y-axis. So our goal is to use the current equation, create a new one based off the fact that it's reflecting across the x-axis. I'm sorry, I keep saying x, the y-axis. Well, if it's reflecting across the y-axis, that means my x has to become negative. That was that property that we talked about a couple of days ago. And we looked at a couple of different examples of when the x is becoming negative and the graph flips over the y-axis. So in my equation here, if I want to create a new equation for g, I'm going to go to where I see x and I'm going to make it negative. Just the x. Because the x value is becoming negative is how it flips over the y-axis. Well, if I simplify that, I have 3 times negative x. Well, that's negative 3x and then negative 2. So my new function, or my line that would have a reflection across the y-axis, would be a negative 3x minus 2. So the slope becomes negative, and then therefore it's reflecting over the y-axis. All right, let's think about the same thing. So if I go to the next one, this one says a reflection across the x-axis. So now it is up and it should be going down. And remember that happens when I take my function and I make it negative. Or the y values are becoming negative. So I have this original function still. We're dealing with this line, 3x minus 2. And it says I'm supposed to make the function negative. F of x is supposed to be negative. Well, I'm trying to create this new equation. And if I make the function negative, that means I need to make all of this negative. That's my function, that's f of x. So I need to take it and make it all negative. Well, that new equation that would reflect across the x-axis becomes negative 3x, but plus 2. So now I should see a reflection over the x-axis. So hopefully, kind of thinking about what the y-axis reflection means and which variable is becoming negative, or what part of the function is becoming negative, hopefully helps that create you a new equation. This last problem is a little different as well. It says that we have this graph shown, and it's sketched from 0 to 5. Again, that just means that it's not going beyond these two values at 0 and 5 for the x. So I'm going to sketch this again on the graph, and then we're going to see if we can remember what it means for a function to be even. So plotting my points here, this looks similar to the one that we have. All right. So this is our original graph. There we go. In the first part for A, since it says we want the graph of h of x, if h of x is an even graph. So I want to take what we have, and I want to complete this function by making it an even function. So we need to think about what does it mean for a function to be even. Even functions have a specific type of symmetry. What type of symmetry do even functions have? Well, it has y-axis symmetry. That means the y-axis should cut this graph in half. So if I take the current graph that I have and I repeat that same graph on the other side, then the y-axis should split it in half. So essentially, I need to make my x values negative because it's going to flip across the y-axis. So I have a point at 2, 2. Now I'm going to have a point at negative 2, 2. I have a point at 3, negative 1. So now I have negative 3, negative 1. And I have a point at 5, negative 1. So now I have negative 5 and negative 1. Now if I look at my final graph, this is an even function. It has y-axis symmetry. All right, we're going to apply this again. So I'm going to go to bar B and think about what odd function means. Odd functions have original symmetry. Well, if it flips across the origin, that means it's going to the opposite quadrant. And for it to go to the opposite quadrant, or the diagonal quadrant, both x and y values have to become negative. So I'm going to graph this one in red. And I'm going to take my value at 2, 2. If it's flipping across the origin, it's going to go to negative 2, negative 2. So I can see that it's flipped over the origin. Looking at my next point, I have 3, negative 1. Well, they're going to become opposite. So now I'm going to have negative 3, but a positive 1. So it's the exact opposite. My last point is 5, negative 1. Well, now it's negative 5, positive 1. So if it's flipping over the origin, or if it has original symmetry, the opposite or the diagonal quadrant should look identical. Now it's starting to looking like a crazy graph because I have two different symmetries appearing in my graph. The last one says we want to show a reflection with respect to the x-axis. So again, if it's flipping over the x, what's happening with the graph? Well, we have to change the y values, or the y values become negative. Let's do that in a different color. Go with blue. I need to make the y values negative if it flips over the x-axis. So again, if I look at this point, I have 2, 2. X is staying the same. It's flipping over the x-axis, so it's going to be 2, -2. My next point was at 3, -1. Well, my y value needs to become negative. Well, it already is negative, so that means it's going to be the opposite, and it's going to be positive. Same thing at 5, -1. It's going to do the opposite and become positive. So that graph, compared to the graph that I have drawn in black, now has flipped over the x-axis, or its reflection with respect to the x-axis. So hopefully that helped go through all those problems. If you have any questions still remaining, please send me an email and I'll try and answer as much as I can and explain as much as I can. If I even need to send you a little video, I can do that as well. The task for today is to start reviewing for the first half of this chapter. And apparently I don't have the review sheet pulled up, so you're going to have to bear with me for a minute here. I thought I had this pulled up. I apologize. Totally not prepared. I'm going to talk though as I find it. So we are done with the first half of the chapter. The first half of the chapter really dealt with functions and their graphs. How do we know something is a function? Can we evaluate a function? We applied the difference quotient to a function. And then we really started looking at the graphs of functions. And I think my review worksheet is already in my packet. Silly me. So the first review worksheet that I have for you to do today starts to begin reviewing the concepts that we looked at with functions. And the first concept we see here is domain and range. Remember, the domain would be the x and the range would be the y values that are defined in the function. For the domain, I want you to try and do as much as you can algebraically. So think about what parts would be restricted for the domain. Well, I know a square root has to be greater than or equal to 0, and I know a denominator can't equal 0. But there aren't any other restrictions. Any other function works. So square roots have to be greater than or equal to 0. Denominators can't equal 0. The next section is actually a review of what we were just working on. So this is those transformations and wanting you to take one form of an equation and write it as a function. So the first thing is to notice what type of equation we're looking at. Well, for letter A, we have the quantity x plus 3 and it's squared. So my x squared function is f. So remember, we're using that function notation. I'm now saying I'm using function f. This graph is shifting to the left 3. To show something shifting left, it has to be in parentheses with x. So taking it from equation notation and writing it as a function. Question 3 down here wants you to write a definition for the piecewise function defined. A definition is another way of saying write an equation. So I want you to come up with the piecewise function, or really the equations that define this function. And if there are 2 parts to the graph, there should be 2 equations. It says each tick mark represents 1 unit. So when you write the equation of a piecewise function, remember, you're going to have the equation sitting over here, and then you're going to have the domain of each piece listed next to it. And then it also asks you to find the range. But when you're writing the piecewise function, you're going to think of what the equation is for each one of these graphs that you see. So it looks like a parabola and a line. And then I should have the domain listed next to its matching equation. That's how we write a piecewise function. The last part of this worksheet is this difference quotient. So the difference quotient is when we're applying the quotient into the x values of the function. On Monday, half of you will get to be in class, and we will go over a couple of these questions. I will have a warm-up or a review activity that we do together as a class, and then we're just going to continue to work on more problems. dealing with reviewing for the first half of chapter 1. Tuesday, we're going to do the same thing, except I have a graph, and we're going to do a lot of analyzing of the graph. And then again, we'll go through some other questions to continue reviewing. And then Wednesday of next week, you will have a test. We'll all be remote learning on Wednesday, and you'll have your first large test on the first half of this chapter. So if you have questions, please email me. I want you all to have a wonderful weekend, and I'm really excited to see you on Monday. Have a good one.